Assalamualaikum. So inshallah in this video we are going to learn about the mechanism for the nucleophilic substitution reaction of haloalkene. In our previous lecture we already learned about the reaction or the nucleophilic substitution reaction of haloalkene when the haloalkene is reacted with nucleophile. So now we are going to focus on the mechanism. So what is mechanism, right? So basically the mechanism for nucleophilic substitution reaction of haloalkene is about how the nucleophile is going to attack the haloalkene to form product. Okay, so basically mechanism is, write down here, mechanism is how the nucleophile, okay, will attack the Rx. Rx is our haloalkene, okay, to form product. Okay, to form product. Okay, so in the nucleophilic substitution reaction of haloalkene, so basically we have two mechanisms, okay, two types of mechanism on how the nucleophile will attack the haloalkene. It is called SN1 mechanism, and the other one is called SN2 mechanism. So there are two types of mechanism on how the nucleophile will attack the haloalkene to form product. Okay, so what is SN1 referring to? Okay, so basically N is the nucleophilic, S is the substitution. Okay, so as we said earlier, this is a nucleophilic substitution. So why is it called SN1? So it is nucleophilic substitution, and it is 1 because it involves only one substrate or one reactant or one molecule. Okay, to make it easy, it only involves one molecule in the rate determining step. Okay, it only involves one molecule in the rate determining step. While for SN2 reaction, so we can see here, N is the nucleophilic, it's just now nucleophilic, S substitution, okay, and 2 because in this reaction it will involve two molecules, okay, in the rate determining step. Meaning, okay, rate determining step. Rate determining step. Sorry, you can see, you cannot see that. I'm sorry about that. So for SN2 reaction or SN2 mechanism, so N is nucleophilic, S is substitution, 2 is it is because in this mechanism it will involve two molecules in the rate determining step. Alright, if we can to talk more about this kind of mechanism, okay, so look at the general equation. Alright, so we have a haloalkane react with nucleophile. Okay, so we know that it will undergo nucleophilic substitution reaction where this nucleophile will substitute the halogen. Okay, nucleophile will attack to the R here and the halogen will taken out. So this is the product that we are going to form, and the halogen just now X will become X minus. Alright, so if we can try to write the rate law. Okay, for the rate law. So if we have a SN1 reaction, okay, so we can see here in this equation, in our equation, we have two reactants, the haloalkane and also the nucleophile to form the product. Alright. However, for the SN1 reaction, the rate law, okay, we learned about rate law in last semester, okay, in the reaction rate topic. Okay, so rate will be K is the rate constant, times the concentration of the haloalkane only. Okay, because in SN1 mechanism, only one molecule involved in the rate determining step, and that one molecule is the haloalkane. Only haloalkane involved in the rate determining step. While for the SN2 mechanism, okay, if we can see the rate law, rate will be equal to K times the haloalkane Rx here, and also the nucleophile. Do you still remember how to write the rate law? Okay, it is like this. So for SN2 mechanism, the rate law will be rate equal to K times concentration of haloalkane and also the concentration of nucleophile. Meaning that in SN2 mechanism, both of the haloalkane and nucleophile involved in the rate determining step. Okay, in the rate determining step. Alright, so based on this rate law, okay, if we can refer to the rate law, so how about, or how to write the, or how to determine the order of reaction? Okay, so if we can see from the rate law, for the SN1 mechanism, it only involves the haloalkane. So because we only involve one molecule here, therefore the order of reaction will be the first order reaction. Alright. Meanwhile, for the SN2 mechanism, because it involves the haloalkane and the nucleophile in the rate determining step, therefore the order of reaction will be the second order reaction. Okay, because it involves 1, 2. So second order. SN1 only one molecule involved, so that that will be first order reaction. Okay, so now we will come to the very important part in this video, which is the mechanism itself. Alright, so please pay attention to what I'm going to talk about. Okay, for SN1 mechanism, remember for SN1 mechanism, you have to know, okay, how the mechanism works. Oops, sorry about that. How the mechanism works. Okay, how it works. So for SN1 mechanism, okay, how it works is, right, it involves two steps. Okay, the mechanism involves two steps, and the first step is the formation of carbocation. You have to know that for SN1 mechanism, it involves two steps, and step 1 will be the formation of carbocation. And then after we form the carbocation, then only come the second step where the nucleophile will attack the carbocation. Alright, C+. C+ there is carbocation. Oops, sorry, you didn't see that. Okay, second step, nucleophile attack the carbocation. Alright, when I just want to move a little bit here. Right, so when we already know that for SN1 mechanism, okay, how the mechanism works is the formation of carbocation ion. And when we talk about the carbocation ion here, okay, what you need to know? You should know about the stability of carbocation ion. Okay, stability of carbocation ion. When we talk about carbocation ion or formation of carbocation ion, we should relate to its stability. So which one is the most stable carbocation ion? So we already know that the tertiary carbocation ion is more stable than the secondary carbocation ion and the primary carbocation ion. So therefore, for SN1 mechanism, we should form a tertiary carbocation ion. We should form a most stable carbocation ion to make the SN1 mechanism happen. Alright, we need a more stable carbocation ion so that SN1 will happen. Right. Okay, that is for SN1 mechanism. Okay, so therefore for SN2 mechanism, meanwhile, you have to know as well how it's work. Okay, for SN2 mechanism, it's only involve one step. Okay, it's only involve one step, and that step will be the nucleophile attacks from backside. This is very important. Remember, in SN2 mechanism, how the mechanism works is that the nucleophile will attack from the backside. So, I just want to emphasize here, for SN1 mechanism, how the mechanism works is two steps. The first one is the formation of carbocation ion. So, for SN1, we will form carbocation ion first. And then when we talk about the carbocation ion, you should think about the stability of carbocation ion. So for SN1 mechanism, we should look for the formation of the most stable carbocation ion, which is the tertiary carbocation ion, to make SN1 mechanism happen. Alright? While in SN2 mechanism, it only involves one step, which is the mechanism works when nucleophile attacks from the backside. Nucleophile attacks from the backside. Right? Okay. And then finally, before we go to the mechanism, I just want to mention the other factors that affect the mechanism. Okay, remember just now for SN1 mechanism, we will form carbocation ion. So factors affected is the stability of carbocation ion. Okay, where we should form a tertiary carbocation ion for a SN1 mechanism. Okay, other than the stability of carbocation ion, okay, the other factors affected is the nucleophile, is the strength of nucleophile. Strength of nucleophile. Where in SN1 mechanism, we only need weak nucleophile. Okay? We only need weak nucleophile, okay, to react with the carbocation ion. Meanwhile, for the SN2 mechanism, okay, we need strong nucleophile. We need strong nucleophile. Example, we need OH minus, we need cyanide ion. Okay, we also need maybe the RO minus ion. Okay, the alkoxide ion. For SN2 mechanism, we need strong nucleophile. This is the example of the strong nucleophile. SN1 mechanism, the first factor is we need more stable carbocation ion. And secondly, we need only weak nucleophile. Example of weak nucleophile is maybe H2O or ammonia, NH3. Okay, because this molecule doesn't have the negative charge. They only have lone pair. Okay, so these two known as weak nucleophile. Alright, so in the next video, we are going to see the mechanism for SN1 and SN2.